So, this fine Monday, I'm doing another update on the state of my 90s sci-fi shooter. Let's jump into what I have in store. So, some things I've worked on. I got a new enemy uh, figured out and partially implemented into the game. I've got some general improvements, and then I got a little preview of vehicles and my progress on that. So last update, I showed that I had these persistent entity weapons. So just demonstrates I can still drop them on the ground, pick them back up, and it's the same entity. What I've worked on is I now have this new enemy. I showed it in my texture baking video. This is my inspired by Halo's Elite's enemy, and you can see he's holding a weapon and it copies all of his movements. It's a little bit janky, but it is well, it's come a long way since I started trying to get this set up. So it almost perfectly follows all of the movements that the enemy makes. It turns with him, it walks with him, and it's roughly where it should be based on his pose holding the weapon. Right now, he's not doing any animations because I would essentially have to make every animation for both the monster and for the weapon and get them synced up, and that's a coming step, but I can actually kill this guy. Oh, no, I can't. Let's pretend that didn't happen. So I can actually kill this guy. Things always go wrong when I'm testing, but see, he dropped his weapon. Now I can pick up the ammo. This guy doesn't visibly have a weapon, so he crashed the game. But yeah, despite all the jank, there is those improvements. The weapon system does, at some level, function and follow the enemies. I know exactly why they crashed. They crashed because I made some last minute changes. First crash was because I did a last minute change to make me hold one of my weapons instead of one of the Quake weapons, and I didn't set that up properly. I didn't set all the variables beforehand. And the second crash was because I just set an enemy that wasn't actually holding a weapon to drop his weapon when he died. But the infighting in my last video, I showed that wasn't working at all. This is working perfectly in the last couple of tests I've done. There was just a syntax error. And then I think I've made it better from the last time it was working. So now it's really working. You see, one of the sides killed everyone on the other side, and then they returned to their designated positions, the waypoints in the map file, which I can pull up. So yeah, they returned to their destinations there. And then the last thing I wanted to show, of course, was my new vehicle. You can also see I have skins on my enemies, so if I want to be purple, I can send it to be purple. If I want it to be red, you can be red. But yes, as a preview, I am working on getting vehicles into Quake, and this is my first vehicle model. It has animations for the tires spinning and turning, and I'll eventually add more animations on top of that, but doesn't drive quite yet. I've been working on getting all the physics written out. The physics are all going to be done in game script. I can pull that up too. Let's see, truck.qc, if I expand that out. Basically, taking in inputs from the player to move, determining all sorts of vectors to do with each of the four wheels, calculating not a true calculation of normal force and grip, but an approximation based off of the velocities, because you can get kinetic energy from velocity, and kinetic energy is proportional to the force that you would have. So it's all an approximation, but yeah, I basically have to rewrite this all because it's all being calculated in the wrong order. But I have a plan for a vehicle. The truck will drive in a fairly natural way, steering from the front, turning from the front first, and falling with gravity, naturally being able to step like the player steps over small ledges. And then there's also a suspension model with a just a travel ratio, nothing fancy there. So that's pretty much an entire update of what I've done since my last video was uploaded, which was quite a while ago. I hadn't realized just how much I had actually worked on in this time. I spent probably a couple weeks working on just getting the weapons to track, and all the changes I had to do with the weapons and getting enemies to actually fire them in a believable way. And then spent a small amount of time fixing the infighting or the team battles that I showed weren't working last video, and then spent quite a decent amount of time both modeling and figuring out how I was going to physically model the dynamics of basic vehicles in Quake. So I'm hoping my next video is going to be sort of a less of an update thing and more of a entertaining video, just fooling around with the truck in Quake. Potentially, what I would like to do is, if I can get it working well enough, I'd like to show a little silly video playing through like one of the first levels of vanilla Quake using a truck like this, actually navigating through the level and potentially having a little ranger, the protagonist, in the back of the truck shooting enemies. But we'll see how that goes. So to round this update off, I just want to do a brief explanation on how LERPing works in the Quake engine. Just to put this out there, because that was a significant part of getting the weapons to track with the monsters holding them. So LERPing, it's a weird word, but essentially it refers to the interpolation of movements. Quake, underneath everything, it's the monsters use a step-based movement system. So if you see in the right panel, this is for the player, not a monster, but it gets the point across. There's a bunch of these sort of strangely formatted functions, and silently in every function, it's calling for the next function. So from player shot 2 to player shot 3 to player shot 4, there's this 1/10 of a second waiting period. Essentially, that's the time between each frame of an animation. And between these frames, there's calculations being done. So between, say, Monster Run 1 and Monster Run 2, typically you would see AI run and some number inside. So here we have Elite Run 1. We're given the particular animation frame to call with this function. The next function that's called, so in this case, it's just a cyclical, goes back to Elite Run 1. So I only have one animation frame for running, and they'll always run 14 units. And so that 14 units is the distance traveled by the AI in 1/10 of a second, because I didn't define a different length of time between animation frames. And so what you can do then, and what the engines do, is they say the standard time between frames is 1/10 of a second, and the distance traveled between frames is 14 units. So what the lerping does is it interpolates that this enemy is now moving at 14 units in a tenth of a second, so 140 units a second for that 1/10 of a second time period. So if you want an item to uh, track the exact movements of a monster with that interpolation, with that lerping, then you have to set its velocity to 140 units a second, or the distance you want to travel divided by the time you want to take for it to get there. Otherwise, you can also, of course, give that item the same commands. So you could tell the item to use the move to goal or the walk move function to move the same distance using the same parameters. Uh, but depending on what information you have readily available, you could also set, you just directly set the velocity, and then that would allow you to also add other velocities to take into consideration the physics. So if you just tell a flying item that's not on the ground, like a held weapon, to walk move alongside an enemy, well, that enemy is going to have different collision than your weapon. The enemy might stair step up, whereas the weapon isn't on the ground. And so walk move wouldn't work perfectly or work correctly at all uh, as a way of copying the enemy's movements to that weapon. So that's why I'm using these substitution functions. So I substituted out a move to goal, change yaw walk move to these functions that it calls the original function to the engine, but then it also calls these copy functions, which reach out to the child entities and do the basic calculations of what's the delta between where I am and where I want to be at the end of the frame, and then multiplied by 10, which is the same as dividing by a tenth of a second.